So we're working very closely with ARM to enable a virtualized compute subsystem for automotive that then brings that shift left and virtualization capability. Now, there are some kind of unique points to doing it in automotive where that capability has real-time components to it as well. So at certain points, especially on the lower levels of the software, when you're really trying to ensure that you're achieving the required levels of safety, you want very, very accurate, potentially real-time accurate virtual models of the device. So there's actually quite a lot of work, and I really appreciate the tight collaboration we have with ARM, for example, around Xena to offer a true virtualized, real-time, accurate software development environment for Xena. What we're doing with ARM is, how do you deliver a platform, a complete compute subsystem that is ready to go, and that the whole ecosystem, whether it's the tier ones, whether it's the OEMs, they can adopt that and they can deliver these new cars of the future to the customer. One thing that I might add here that is really unique and exciting about this collaboration is that ARM computing is at the heart of the vehicle of the future, but ARM computing is also increasingly at the heart of the data center. So in fact, when we do this virtualization, when we're running our full stack of Cadence tools for functional safety, certification, and validation, that actual stack that is then run in a traditional data center compute can also be running on ARM. So for example, we actually have this concept of native virtualization, where if we're virtualizing the Xena ARM compute subsystem, that virtualized system, if it's actually running on an ARM server in the data center, it can run natively on that Neoverse ARM real bare metal silicon underneath the virtualization. Or when we're running our Excellium functional simulation and fault campaign as part of an ASIL BCD certification, those Excellium simulation jobs can be run on ARM computing in the data center. And we definitely see really material cost performance TCO benefits from what ARM is doing on the data center side as well, which is very, very exciting, I think, for the ecosystem. Safety and reliability of the AI accelerator in autonomous drive is incredibly important, right? You absolutely need to trust your self-drive capabilities. Again, making sure that we have a full stack end-to-end for the NPU for the ASIL certification is one of our priorities. And there are some nuances and differences there, what kind of safety mechanisms, how you mitigate the risks in AI, and particularly, which ones you try to do, which risks you try to mitigate in silicon versus which ones you mitigate within the software stack and the actual AI itself.